The main source of our data is gunviolencearchive.org. However, we found a well-structured and more usable form of the same archive on Kaggle, which we use for our analysis.
Gun violence incidents have long been a serious security problem in the US, so we are going to analyze and try to gain insights about them.
There are many forms of gun violence. Incidents result from unintentional shooting, defensive use, home invasion, and mass shooting. The number of gun violence incidents in the United States have been on the rise. Our data contains incidents up to March 2018. The numbers have been rising since then. In Virginia, there have been around 6,500 incidents. Thus, we plan to improve safety in Virginia with our analysis.
The dataset is get from Kaggle, which is already well structured and easy to use. As the first step, we only focus on data about Virginia. There are some columns we are not going to use. Also, the format of some columns need to be transformed before we can actually use them.
So we extracted data from delimited format and converted to different columns. Most of our data is spread from 2014 to 2017. We found the cities with the highest incidence and the state capital Richmond ranks on top. We found some interesting correlations. If there are more male participants, then the suspect is more likely to be identified. If there are adult participants involved, then they are more likely to be male. However, we did not find any direct correlation with location, which is strange as we just observed that some cities are more prone to gun violence.
After data preprocessing, we start from using classifications. And here comes the first challenge. Since there are no labels in the dataset, we need to make the labels.
We applied PCA to find a column to choose as a label, but TC did not give us clear cluster boundaries.
The method is using one column as the label and using other columns as features to predict the label. We tried using different columns as labels and draw ROC curve to show the results. Some AUC ratio is rather close to 1, indicating that the label is highly predictable by other columns. For example, whether there are people arrested is highly predictable by other features. This can be a powerful model because when a new incident happens, we can predict whether there will be people arrested by other features of this incident. Meanwhile, some results does not make sense at all. During this process, we learned the importance of our prior knowledge by which we can set the right labels and get the good results.
Then we try to have more insights about the gun violence data. We apply the k-means algorithm to cluster it, and we try different numbers of clusters ranging from 2 to 14. Here we show the plot for 3 clusters. Different clusters are shown in different colors. To find the optimal number of cluster K, we first plot inertia versus K. Of course, more clusters leads to less inertia, so this graph does not help much. But there is an elbow in the graph for K equals to 2. Probably the optimal K is around 2, because as K increases larger than 2, the inertia goes down slower. We tried another method to find optimal K called silhouette score. In this method, higher score means better K, and we found that the optimal K is 3. We printed the centers for 3 clusters and found out that the incidents became more violent because there are more people killed or injured in more recent incidents. To find the possible factors in gun violence incidents, we found other data on poverty, unemployment, and education from US Department of Agriculture website. We merged all the data we have to one data frame. Unexpectedly, from the correlations we can see, the number of people killed in the past 5 years is not much related to any of the possible factors we thought, like poverty, unemployment, or education.
So far, we have already gained some insight about the dataset, and we will keep working on it to get more useful conclusions and models, and we will describe them in the final report.